Welcome, this is where nerds come to learn things. If it's your first time here, click on the subscribe button and on the bell icon to get notifications about new videos. Thanks for watching, hope you enjoy it. Hello, this is a little multimeter I've been given from Banggood. Now Banggood sent this to me free of charge, so you know, it is what it is. I try not to be biased, I'll give my honest opinion about things. So we'll open this up and we'll go through it. So thank you very much Banggood for sending me this meter. We'll get to have a bit of a play around with it. There'll be links down below in the description for a link to this meter if you want to take a look at it yourself or buy one. Or anything else from Banggood. If you want to buy anything from Banggood, I'll use the link because it gets tracked back to me anyway. Okay, let's have a look. We've got some meter probes. What are these like? These feel like PVC, but they're quite well plasticized PVC cables, so they feel okay. Plugs look okay, I suppose. They've got split terminals in there, as you can hopefully see on camera. Probes, not very sharp. They also feel quite rugged. There's a nice strain relief on here too. It's nice. That's quite nice. They say 20 amps, but I doubt it. That's probably because that says 20 amps on the meter as well. The cable says RHS on it. Are there any other markings on the cable? Doesn't seem to be, only RHS. So this, I don't believe the 20 amp rating. A bit of sharpness to them, but they're not super sharp. What else do we have? Here we have a temperature probe. So a nice little handheld probe. That's quite nice. Split terminal connectors there. Just standard thermocouple there, you know, nothing particularly exciting there. But it's a nice stretchy cable, so if you need to use this for, you know, pinpoint testing of things, then this could be really handy. And I can actually think of a use for this right now. Something I'm working on. So that's actually quite nice. Instead of the standard thermocouples with this flying lead, which is that's a bit nicer. I'll put that back in the packet. And manual. Let's see. So it's a 40,000 count meter. Manual doesn't look too bad actually. Lots of features, not going to cover everything. Maybe I'll do this. I mean, yeah, you can have a look, read it yourself if you like. Okay, just freeze it or something and have a read. I'm not going to read it all out to you. You're adults, I'm sure. Probably, maybe kids, I don't know. The basic things: 1.1% accuracy, 0.8% reading, plus 10 digits. Okay, not sure about 10 digits. Plus 10, maybe. It's pretty much similar specs, 0.5% on these ranges. I'm not really into the whole metrology aspect of multimeters and the detail of them. So you can make of these what you will. I mean, to me, on the surface, these specs look okay. There's nothing here which looks out of the ordinary as far as, you know, accuracy. Capacitance plus or minus 10% of reading, plus 20 in these like 999 UF to 99.99 millifarad. Yeah, I mean capacitors you pretty much expect anyway. But there's nothing looks untoward there. Diode continuity tests. Diode test up to 3.2 volts, which is nice. You can test LEDs with that. Should be able to. You've got non-contact voltage as well. Transistor testing, but I have to say I've only never really used that myself in the past, not really. And some basic instructions on how to use the thing, which I'm not going to read because I don't read manuals unless I need to. Right, so let's have a look at the meter. So it's got a nice tilting bar on the back there, which feels like it latches. It doesn't want to lift up. That's quite stiff. That's one hell of a action on that. Wow. It's got this plate which screws down. Yeah, let's just have a look at that already. We will pull it apart as well, I think. So you've got this plate which screws down. It's slightly nicer. Yeah, it's got a lot of tension on that thing. Interesting design. It's got a magnetic mount on the back there too. Battery, well, I'm guessing you have to get this cover off somehow. Whether or not to take the buffer off, I don't know. Maybe not. Let's get my other screwdriver, because I have to fit a battery anyway. Should I take it apart before I turn it on? Do a Dave? What do you reckon? No, I think I'd rather turn it on first and test it and test the basic functionality. Then maybe I'll pull it apart properly. Alright, so that's that. There we go. Okay, so that just comes off as one piece like that. Fuses are accessible in there. That's not bad. They've got some ceramic fuses. Rating, that one says 20 amps. And that one says, looks like 500 milliamps, it looks like. And as you can see, it takes a 9 volt battery. Interestingly, the holder is actually designed to take some AAs. It's an AA battery holder, but they've obviously decided to go with 9 volt. Very interesting. Well, let's plug a 9 volt in. So I wonder how to get this thing completely apart. We'll get to that, I suppose. We'll get to that. Let's just do this for now. Let's have a play around with it first before I pull the thing right apart. Check its construction. So again, the links will be for this down below in the description. I might have to tighten it back up a bit. I don't know, a bit too loose. Interesting tilt barrel design. Very interesting design. You can actually go right around like that with it. It's pretty cool actually. It's not bad. It's not bad. Right. We've got the screen protector. Let's peel this off. Not a virgin anymore. Right. So it's got off at both ends, which is quite nice. And it's got these covers which switch around between which range you're in. So which function you're using, it will change and hopefully stop you from doing something stupid like leaving things plugged in the wrong place. So if I go around to say current, so I've got 20 amps there, if I plug that in, does it stop me turning it? It does, it stops me turning it. So that's actually quite a nice feature. You can't get it out of that range unless you unplug it. So, okay, do the same for that one. So microamps, yep, amps won't go, HFE, a little bit of those, won't go any further than that. Okay. So it stops you from accidentally having your probes plugged in the wrong place, which is a nice feature. So it's got capacitance range and stuff like that, so microamps apparently. It'd be nice to try that actually, see if I can get something that reads that low. I do actually have some test gear, I should be able to do that, so we'll see how we go with that. And off at the other end. Non-contact voltage as well. Sometimes you can trigger it by... There we go. Alright. So that works. Yeah, it works. How close? That's not bad. Yeah. Could live with that, I suppose. EF. I don't know what EF means. Frequency. So we'll check all these functions out. And we'll go through them and see how they actually perform. So we've got resistance, diode and sounder. So you should put select as diode test there and continuity test. Millivolts, volts, DC and AC. So you push the select button to choose one you want. Does it default to one or the other? Defaults to DC, go AC, go back round, goes back to DC again. So it defaults to DC. Push it back to AC, turn it off, turn it back on, back on DC. So it defaults to DC, which is nice because it's most likely to be using that on this kind of meter. So that's 40,000 counts. So nice. It's quite a nice display. It's fairly large, I suppose, about an inch high or so. The actual digits are about 18, probably 17 or 18 mil high, the actual digits. Alright, so the whole screen is say about 40, just under 40 or so, 35, about 30, yeah, 37, the whole screen, something like that. So it's not bad. Does it have a backlight? Well, it's got ranging, manual ranging. Relative measurements. Dollar hold. AC auto. That's obviously this range auto ranging. Auto power off, auto backlight. Oh, it does have a backlight on there. I did see a bit of a backlight. No, I'm sure I saw a backlight. Can't see it now. But it's got auto backlight apparently. Somehow. Am I going to have to read the manual for this? Most probably. Okay, let's do some checks and I'll figure out the backlight thing afterwards. So let's look at the original probes. We won't look at my own ones. I'll use the ones that came with it. So common there. Volts. So we've got diode test, sounder, capacitance, volts, ohms and hertz all on that same test point. All on that same probe point. So let's go to resistance. Let's look at the default resistance without anything calibrated or reset. Well, it's showing 0. That's not bad, is it? Okay, let's look at the diode test. It will show 0 as well. Okay. Sounder. A bit slow. It is latching, but it's a bit slow to actually activate. It is a bit slow to respond, but it's not that bad. I've certainly had worse. You know, if you're probing along something, you know, say this for example. You know, yeah, I missed. Hope you can see how quickly I'm doing it. It's varying a little bit. It's not too bad. I've certainly seen worse. Okay, so that's that function. Capacitance testing. Let's get a cap. Here you go. Let's get a 10 UF cap. Let's see what this thinks of it. Yeah, 9.8. I don't know what a test frequency is. So let's just look at a even larger one. Let's go to a 220 UF. Can I get the probes on that? Yeah, sort of 10% out. I did kind of say that, didn't it? 10% accuracy. But again, it depends on what frequency it's actually measuring at. Let's have a little look. Does it say what frequency it was it's measuring at? Capacitance. Doesn't seem to say. Could be in there anywhere. It says auto LCD backlight. It doesn't say much else about turning it on. Auto power off as well. 15 minutes. That's right. It's reasonable. Don't see it saying what the frequency is for the testing. Might have to look at that and figure out what the test frequency is on this. Let's fire up my Siglent and chuck that in frequency mode and we'll see what frequency it sees from this meter when it's trying to do capacitance testing. 11 kilohertz, 11.3 kilohertz, that's seeing. So 10 kilohertz test frequency, which is probably why it's getting that particular reading. Right. Right. Well, I need to set up some kind of test gear here and actually do some accuracy checks and see what kind of measurements it does. Okay, so I have this plugged into my Fluke DC calibrator. I've got it set to 1 volt. And I've only had it on for about 5 minutes or so, and as you can see it's basically bang on, right? It's not much in it. So let's just increase the range. Let's go to 10 volts. So yeah, it's not too bad. Let's do 100 volts. Yep, 99.95. It's not too bad. I would have hoped for slightly better, but my calibrator's not been on very long either, so it's probably affecting it slightly too. Now, should we try 1000 volts? It says 1000 volts DC max, 750 volts AC max. Right, so it's supposed to be able to withstand 1000 volts DC. Let's try it. 700 volts, 900 volts, 1000 volts DC. Yeah, it's not bad. Hasn't gone bang. Interesting, auto scaling is only showing 10%. Does that mean it's supposed to do 4000 volts? I don't think so. Okay, so let's do some smaller ranges now. We've done the high range, so let's do millivolts. It's 100 millivolts there. Okay, so yeah, that's not too bad. Let's go down to the next range down, see what he thinks of it. 1.97, yeah, it's not bad. Okay, let's go down to 10 millivolts. Yeah, okay, not super accurate, but what is that, 3%? 1 millivolt. Okay, let's do 100 microvolts. That's where it starts really changing it, doesn't it? So let's do 0. That's really -2 there. So let's do relative measurement actually. Maybe that'll do something to it. Let's do back to 1 millivolt again. So yeah, that's actually closer. So maybe that relative measurement is quite important. It's 100 microvolt. 10 microvolt. Yeah, it's not doing too bad. Give it a chance to settle back down to 0 again. Should do. Yep. And the -1 there. Yeah, it's kind of there. 1 microvolt. Yeah, it's barely there. Let's do 5. So yeah, that's reading pretty low. That's not bad at all. Okay, so that's certainly within the range of what my calibrator here can do. So it should be 100 millivolts here. Yeah. 200, 300. 400 millivolts. So there you go, so that's the maximum range. So that's 4,000 count, well 40,000 count as you can see here. And it's doing that, that's fine. Okay, let's check the AC voltage in. So let's plug these into my AC calibrator, which is also on and ready to go. Let's do 1.2 volts. Frequency is a bit high, I'm doing 1 kilohertz, let's do 100 hertz instead. That might be a bit better. Yeah, that's better. Okay, so 100 hertz is a reasonable measurement. I should actually have a look and see what it says about the frequency. Does it say frequency on AC? AC voltage. Frequency range 40 to 1 kilohertz. 40 to 1 kilohertz. Okay, so I should be able to do 1 kilohertz. So we'll wind it up. So I'm currently doing 1 volt. That's 500 hertz. Yeah, okay. 900 hertz. Yeah, and 1 kilohertz. Yeah, it is kind of doing it. It starts to drop off though. Seems to. If I go down to that's 10 hertz. It can be 10 hertz. It's supposed to be 40 only, but maybe it depends on the voltage it's reading. So yeah, I mean it's there. It's only around 50 hertz. That's a nice common AC main frequency. So let's wind the voltages up. So let's go 10 volts AC. Yeah, okay. Actually, maybe I'll go to 100 hertz just to make it a bit more likely to read okay. Less noise involved. So it's reading it out by a few percent there. Okay, so let's do 100 volts AC. Yeah, not bad. It's there. And 750 is the most it's supposed to do, so I'm not going to go any higher with that. 200 volts AC. Once I put it back in operate mode. It's a safety feature, it goes into standby when you go to higher voltages. So yeah, it's out by 0.5% or so, isn't it? So Okay, let's do 500 volts. Yeah, that was 800 then, it beeped, so 700, 800 is beeping. So cool, it warns you it's over voltage. It would be nice if it warns you at these voltages though. You know, it's 400 volts, it should be nice to know if it's 400 volts AC, wouldn't it? Should beep there really. But, okay, so it's working. Okay, let's try and do some low voltages. So that's 100 millivolts. Let's go to AC. 100 millivolts. That's pretty, you know, it's slightly out, not bad. Okay, let's go down some more. That's 50. Yep. Let's go down to 1 millivolt. Yep. Okay. 100 microvolts. Can it see it? Oh, not really. Can't really see 100 microvolts. So let's try a different frequency. No, not seeing it. Oh, we're starting to get something there. Yeah, it's not really microvolts on AC. And that's 100 Hertz. It's just not quite reading microvolts. So let's go 200 microvolts. No, 300. Come on, show it. There we go, starting to get something there. That's at 500 microvolts. So it's, yeah, 600 microvolts. So it's really struggling with those really low levels. So below 1 millivolt is a struggle for it. But then still, it's not bad really, considering, you know, it's not bad. It's quite a low level we're talking about there. So I'm probably being a bit fussy about that. But yeah, that's okay. It's moderately accurate. We'll try some other stuff. Alright, so let's do some testing on some resistances. Now these are some precision resistors I've got. I've actually got some more which I haven't even opened yet, so I'm going to open those. But so let's see what we've got. So it's a Vishay 39K2 0.01%. So let's just clip this on, see what we actually get out of it. Actually I should do a zeroing first, shouldn't I? See if it zeros. Yeah, pretty much zero. This is on my own leads, not on the ones that came with it. Because I've got the clip leads obviously. So it's supposed to be 39.2K. And it's close to what we're getting, 39.22. Yeah. Can I make that range better? Being it's a 4,000 count. Here we go. So it's fairly close in that range. 49.977 apparently. Let's change ranges. So saying 49.99. So it's out by a little bit there. Not much, you're talking small amounts. Okay, what else have we got in here? So here we have a 20 ohm exactly, 20.0 ohm. So 19.9. This is a 0.1% accurate part, apparently. Let's just clip on here, see what we get. That says 0 there, so zeroing is actually really good. Let's try this one. What's this one? This is a 15 ohm part. So it's reading a little bit low on those ranges there. But again, you're talking about 15 ohms, it's really low values. It's not bad. I think I said its accuracy was what down that range. I want to have a look. Resistance plus or minus 1% of reading, plus 10 digits or plus 10. So yeah, that's within its spec at least, based on that one. So that's not bad, I suppose. Is it super accurate? No. Is it good enough? Yeah, I think so. You know, this isn't really a super accurate high-end meter, but my higher-end meters can read those pretty well. It'd be really close. So I'm not worried about that part. Okay, next test is to check some currents. So let's do amps, and I'm showing a 20 amp socket there, which is opened up for us, so we can plug it in. I do like that little selecting there. That's a good little feature. So I've got my Siglent set up to measure DC current as well. What I'm going to do is I'm just going to do a direct comparison between this meter here and what my Siglent 6.5 digit meter is saying. I've basically got them shorted across my power supply, which I've got currently set at 0.5 amp. It'll be thereabouts that amount. Just at 7 volts, quite a low level. Alright, so it shouldn't be huge power, shouldn't be any risk to the meter. Okay, and we'll turn the supply on and see what happens. So that's my Siglent saying 505 milliamps, and it's saying 504. So 1 milliamp out. That's alright. Let's increase the current. Let's go to 1 amp or so. Let's go 2 amps. What the hell? Do 2 amps. Siglent is saying 2 amps with 3 milliamps. So it's 2003 milliamps. It's saying 199 point, that. So this is actually almost agreeing with my power supply, really closely actually. But yeah, the Siglent is reading a fraction higher, 3 milliamps higher. So not too bad. Let's just get a bit more. Do 3 amps. The Siglent saying 3006. This is saying 3002. So it's about 4 milliamps out there. So not too bad. Okay, let's go down to a lower current. Milliamp scale can take 500 milliamps max. So I don't want to stress that. So let's just go to let's do 300 milliamps, right? So we'll see it there as well. 303. My Siglent's saying 304. So 1 milliamp out there. So it's obviously a linear difference there. So let's do milliamps. Chuck it in that one. Power supply's currently turned off. My Siglent auto scale, so I don't do anything with that one. So my Siglent is saying 304 milliamps still, and it's saying 303.8. So my Siglent is saying 304.276 or so. It's bouncing around a little bit, and it's saying 304. So they're actually very close in that range. Very close. So let's go down a bit further. Let's do 100 milliamps. So that's 101.6 on the Siglent. Well, 101.66 on the Siglent, shall I say? 101.48. Again, fairly close. That's within the spec. I think it's about 1%. I think the spec was, so it's within that. And let's go down some more. Let's do 10 milliamps on the power supply there. Cool. This is measuring that. It's so we've got 11.66 thereabouts on the Siglent, 11.63. So again, it's really close. So yeah, it's all within ballpark. It's fairly accurate, really. It's not super high precision. It's within the realms of acceptable. Certainly, it's within the specs. It seems to be, at least. So let's look at. So what's microamps? Is that in the same range? I think it is, isn't it? Yes, it is. Here we go. It's as low as I can get my power supply to go. That's saying 1 milliamp on there, so obviously it's not 100% accurate on the power supply. It's my core and does the job well enough. So my Siglent's saying 3.18 milliamps. So that's 3.189ish. It's similar. There's not a lot in that. Probably less than 10 microamps because they're both bouncing around a little bit. They're very similar again. So again, I think that's pretty good. And that's that's about 10 microamps. 10 microamps difference. Siglent's saying what, 3.192 or so. Again, it's bouncing around slightly because it's right at the bottom end of my power supply can be set to. Accurate enough. I do like this. The way it changes those around. That's a really nice feature. That will save a lot of people headache. A lot of accidentally blown fuses, that kind of thing. Or shorted out supplies or whatever. We've all done it. That'll save people, certainly. Well, we haven't done frequency yet. We need to do frequency, don't we? Okay, I've got this hooked up to my Keysight oscilloscope, which has got a wave generator built into it. And it's currently generating a 1 kHz, 1 volt peak to peak waveform, and it's reading basically 1 kHz. Now the spec on this thing is plus or minus 0.1%, plus 5. So 0.1%, yeah, that's within that, isn't it? What I'm going to do, I'm going to drop the voltage down, and we'll see what voltage level it drops out at 1 kHz. Because I always have a threshold where they stop working. Oh, that's getting a bit flaky. There we go. So that's actually fairly early. Actually, I'm surprised by that. So it seems to be struggling about there, which is about 830 millivolts peak to peak. So that's like the actual bottom limit, it looks like. So if I do 850, it's now reading okay, just so 850 millivolts at 1 kilohertz. So okay, we'll go back up to 1 volt, and then we shall adjust the frequency, and we'll see what frequencies we can drift it down to. So, 60 hertz. Yep, that's reading fine. 20 hertz. Yep, that's actually bang on there. 1.5 hertz. Yep, it can do that too. 100 millihertz. No, I can't do that. Let's not that voltage level. Let's increase the voltage. Let's go 2 volts just to give it a bit more of a chance to work. No, just can't do 100 millihertz. So let's go to 500 millihertz. Nah, can't measure that low. 700, nah. 800's starting to work. So 800 millihertz is like the bottom limit, and that's the 2 volts. I'll go a bit more voltage on it. Let's go 5 volts, and we'll try dropping our frequency down some more. Let's bet down to 300 hertz, 300 millihertz. Sorry, nah, I can't get it. So looks like 800 millihertz is this limit. That's 700 millihertz, 800 millihertz. That's where it starts to reach 800 millihertz. So it's probably got some internal filtering or something like that to try and stop noise from affecting the readings. Entirely possible. Okay, so let's wind the frequency up. So let's see what we can do. That's 2.5 kilohertz. Yep. 24 kilohertz. Yep. Let's do 100 kilohertz. It's 100 kilohertz there. Yep. This is still at 5 volts. So I'm going to drop this voltage down a little bit, down to say 2 volts. Actually, let's go 1 volt. Gives us a bit of idea of thresholds. 240 hertz, kilohertz, sorry. Yep. 500 kilohertz. Yep, it can do that too. Okay, we'll keep going. 1.2 megahertz. Oh, it's struggling a bit there. Okay, let's just try a bit more voltage. Yeah, there's a bit more voltage there. So I did 2 volts. Now it's just about okay. Alright, let's go to 1.7. Yep. 2.6. Yep. 4 megahertz. Yep, still that too. Okay, keep going. 5.1. Yep. 7.5. Yep. 20 megahertz. No. Give us more voltage. 3 volts. No, I think that's too much for it now. 4 volts. Nah, it's not getting it, is it? 5 volts. No, I can't do 20 megahertz. Okay, let's drop this down. Let's keep going. 16 megahertz. Yeah, I can do 16. So make sure you can test oscillator crystals, most likely, on things like Arduino stuff like that. You could probably be able to do it than that. Okay, so let's just see what the limit is. 17, 18, yep, 19. You can do 19. Just can't get to 20. So that's not bad, 19, even though that's not too bad in itself. Let's drop the voltage down to say 1 volt. And it's still almost reading at 19. 18 again. Yeah, so it's not bad. So it can actually cover basically up to 18 megahertz, I'd say. Pretty comfortably. So I'll be happy with that. Duty cycle. Yeah, 50%, that's fine, because I'm doing a sine wave right now, so that should be absolutely right. Square wave, and we'll see about changing the duty cycle on a square wave and see if we can check the accuracy on that as well. So duty cycle, let's go down. Let's go. This is currently 4.7 kilohertz, which might be a bit high for a square wave actually, but So 20% duty cycle is what's on now. Can't see it. Voltage 1 volt, let's go 2 volts. There we go, that's better. So it's about thresholds there. So I can see 20%, it's 2 volts. Let's do 4%. No, it's not really, it's dropping out. 10%. So I'm on 11% right now, sorry. 10% is there. Okay. Let's give it a little bit more voltage. 2.5 volts. Duty cycle 5%. Yeah. So it just needs a high enough voltage in order to get that threshold enough so I can actually see those short pulses. 1% duty cycle. And there we go. And that's at 2.5 volts. Right. So again, 1 hertz. So I can do it. Let's go the other way. Let's turn it right up. Let's do 95%. There we go. Yep, 95. That seems fine. It seems to be able to do what it's supposed to do. 99% duty cycle. Yep, cool. So that all seems to work absolutely fine. Well, I suppose I should do this transistor test function since it's got it built into it. Right. Oh, I'll take this out of there. See, it stopped me from doing it. Interestingly. I'm going to go there though. So HFE we want. This is a 2N3904. And it's emitter base collector, I think it is. Let's just double check. Yep, emitter base collector. So you want those holes just there. I haven't done this in years. Right. Can I get a connection in there? Not the best. It's kind of going in. Is it? Isn't it? I don't know, is it? It's not the best kind of connections in there. It's really doesn't feel positive, you know. It sort of doesn't really feel like it's plugging into anything. Well, as expected, I think the transistor testing HFE is a bit of a toy. It says 222. Is it? Oh, I've got absolutely no idea. Maybe it is. Maybe it isn't. I probably can verify that. With my Peak tester. Let's see what this thinks of it, shall we? Got Peak Electronics, that makes a really nice gear actually. A little bit expensive. I'd actually contacted them once and asked them if they wanted to donate me a an ESR meter, and they never replied, so that was a bit disappointing. So if Peak Electronics happen to watch this video, please get in touch. I'd like to demo some of your meters. Right, turn on. See what this thinks of it. NPN? Yes it is. Yep. 221, which is what we're getting on here. I believe it. Even though it's not exactly a great kind of connection on there. Once it was connected, it was working okay. Let's just shove in there again. It's just not making a very good connection on the terminals inside. Just doesn't really have a good positive connection on there. Trying to make it touch all terminals at once, it's just very fiddly, not really that useful, I have to say. Once it goes, then it's alright. You know, that's exactly what the peak meter said. So in that regard, it's fine. But if you can get it to connect at least. I thought I'd check the temperature functions out, and I've put it onto temperature already, nothing plugged in, and it's reading 27.8 degrees C, and it's actually fairly hot, so I actually believe that's actually about the right temperature. Without anything else. I don't know, is it like an internal measurement? Maybe it will change when I plug something in? I don't know, let's have a look. Don't know. Is it using this probe now? Seems to be, yep. So it's interesting the way it seems to have like the internal temperature. It just reads that first before the probe. So maybe there's a setting on there for that. So if you see anything weird like 45, you know, that'd be concerning. But yeah, I mean that seems fine, doesn't it? No? It looks within the ballpark of what you expect from holding it. 36 degrees. That's probably about what I am. So let's just have a look at this Fahrenheit setting. Okay, Fahrenheit Celsius selection, that's about it there. And back to 27.7 again. So it's almost like it's reading the internal temperature and then it looks at the probes once it beats it. It's a bit odd. I don't know, if I go and chuck it in the fridge, will it cool down? Let's go find out. Okay, so I put it in the freezer for, I don't know, a few minutes, and it's got some condensation on it now. And the temperature did drop, so it is obviously reading some kind of temperature. I haven't let it drop right down, obviously I didn't leave it there long enough. But the case now feels a little bit cooler. It's probably about, I don't know, case is probably about 20 degrees or so, maybe 15. Feels chiller, but yeah. And obviously the condensation. Now the backlight is automatic, so when I had this thing in the freezer, I could see the backlight was on, and as soon as it had enough light, the backlight turned off. So it was an automatic backlight, as it says. So it turns on and off as required. Now the question is, where is the sensor for that? I think it's there across the top. I don't know if you can see it coming on. Can you see this down the side there? Get outside of my lights. There you go. See it coming on? So it's not super bright, but then my lighting here is really bright. So let's turn the lighting off. Alright, yeah. This is going to be quite dark now. Then so it comes up alright. It's not super wonderful, but if you're in the dark, it'll be absolutely fine. Perfectly adequate. So yeah, it doesn't bother me at all. I think that's fine. Alright. Next thing. Let's pull it apart. This bit will probably seem a bit familiar to you if you watched it from the very beginning, where I put a battery in. There. So these are threaded studs, which is nice. Means there's no wearing plastic out. It's actually proper metal inserts. So if you need to change battery, it's not a big deal. The question is how to get the rest of this out. So let's take this buffer off. Try and get that buffer off. Looks like it's over moulded maybe, but no, it's just a really good fit. So it's just a PVC buffer. Nothing particularly special about that. It's got some little locator pins on there. You can see a little hole. It was pushed into there. Also be careful not shearing those off, otherwise it won't fit properly anymore. Oh, let's turn the battery off. Hate other batteries, they always tend to break the holders. Oh god, I hate that. Never like these. Come on. These always end up getting ripped off or damaged because I don't like battery holders. Don't like them. Okay. It must just have little hook catches on it or something. So those are plastic screws, that's fine. It's not like you pull the thing apart all the time. Don't have a problem with that. So how's this go in there? Is it clipped? Yes it is, there we go. Let's try and get this out of here. So plastic, it's ABS. It doesn't seem to say it inside the moulding, but yeah, that's ABS. It sounds like ABS, which is what you expect. So look, so you've got a nice chipset there, HY11P14 chipset, whatever the hell that is, I don't know. Same logo on both devices here. 4.9152 MHz crystal over here. There's a couple of headers, which is interesting. Switch 1. Oh, I wonder what that does. SW1. Maybe it's like a reset. And there's another 4.1952 crystal over here as well. Interesting. So there must be one for each device. Can't see exactly. Yeah, those go to this device. These go to this one. So it's got individual crystals for each one. This is HY3131. So it's obviously going to be a display chipset, and this is going to be a Multimeter chipset. And was that an LED in the back there? That's interesting. What's that? There's an LED. So LED 2. It's right behind the meter there. That's interesting. Oh right, okay. So right on the end of the gauge on the lever there, try and get in shot. I don't even see that just there, but there is a light tube. So obviously when the backlighting comes on, also it lights that up as well. Let's see if I can make that trigger. Never gets battery back on, I'm telling you. Right, let's turn these lights off. Turn it on, cover it up. There you go. Can you see it? So that's actually lighting up the range it's on. So it's actually pointing at it. That's a nice little touch. That's very nice, I like that. It's those little details which make it a nice meter, you know, as people are paying attention to those little things which make it easy to use. Oh, come on. Apart from using 9-volt batteries. Fucking 9-volt batteries. Don't like 9-volt batteries. Fucking things. Right, so what we got in here. So isolation slots, non-existent. We have the current shunt across here, and it seems to have a wire link to that end of that fuse. Very interesting. So it's got screw terminals on here, which is loose. They come out with it. Those are inserts, I think. Probably because of that switching mechanism. Let's pull this apart and have a look. So it's got a little buzzer there, obviously. Some little wire leads there for an LED, which must go around to the display LED. And there's the non-contact voltage sensor there. I see a bit of wire strip just there. So there we go. So it's also for detecting the high voltages. Some kind of programming header or something just here. That's also the transistor socket on the back there. Diode arrangement there. Looks like a diode rectifier actually. Bridge rectifier. It does. But it is. It's a bridge rectifier right there. Interesting design going through that fuse. It's got a PTC. Couple of resistors there. Nothing particularly exciting as far as protection goes. Let's see if we can get this board out. It's got quite a few screws. They look like they're all probably the same. I probably don't have to pull all of them out, but you know, I don't know what I'm doing, so we'll find out. Oh, that's already loose. Is that what I need to do? That's already very loose, even after I took some screws in. Okay, so some of those have hole in the display, so I don't need to take those ones out. Okay, I'll put those back in again. They're all the same screws anyway, so it doesn't matter. Drop that back in again. I don't want the display falling off. Don't need to take it off. It's going to be a zebra strip or something. Not particularly thrilling. So just the plated contacts there, not gold or anything. There is some lubricant on there, I can see it. No, I'm not going to touch it, I don't want to disturb it. So it's got 6 pads there as per this, so that matches up. There's no unused ones. And there's that bloody horrible socket for the transistor test. Oh, just not very nice feeling, not very nice feeling one. But yeah, as far as protection goes, yeah. So let's have a look what we got. So it's got a PTC on that side going to there somewhere. Bridging across. So that's the voltage signal coming up here through that little track up to that chipset. And the PTC comes to this side as well to those traces for these switch contacts. And also the common is all the way. So the common's just straight up the side, nothing, there's no isolation at all from the common. There's nothing there, so on an AC kind of line you could potentially be getting AC coming up the common lines onto other stuff. So yeah, but the lack of MOVs and stuff is a little bit concerning. But it's not really designed for it. But then it does say, whoops, 1000 volts and 750 volts. You know, be careful. Yeah, there's not really much to see on that side, is there? So there's the LED for that backlighting on that, which seems to work okay. And there's the indicators here and the light sensors in the centre. Okay, that's what that is. Switch wise, let's see. It's got some ball bearings on springs. How long will those last? Yeah, who knows. And it's got this cam operated piece here for the on-off switch and the actual covers of each terminal. So it runs in this cam here, which is an interesting concept, isn't it? Seems to work okay. Again, there's no markers on inside this casing saying what it is that I can see at least, but it will be ABS. It sounds like ABS. Right, let's look at reassembling this part. Need to make sure that cam's in the right place so I can actually turn it. Otherwise it won't work. Oh, I'm going to ruin this, aren't I? Ball bearings and springs. Just asking for trouble. Which way up was that? I don't know. I did that way around, didn't I? Pretty sure I did that way around. Okay. Let's just drop that back in like that. Yep, that's the one. That works. So let's just put it back together before I completely destroy it. Yep, that still works. It looks correct. Cool. So yeah, the lack of protection in here is a little bit concerning, so I'd definitely say don't use this on high voltage AC, or high voltage DC even. Although it says it can do it, I would be very sceptical about that. For your own protection, just don't do it. Sort of thing you expect from these non-mainstream meters, because they don't always have optimal safety in mind. So, you know, they look at the feature set and not necessarily best MS. Mind, it's just Cat 3 over here, Cat 3 1000 volt. I doubt it. Cat 3, I'm pretty sure you need isolation slots and MOVs in there for that. There's no MOVs. No, I don't believe there's Cat 3 at all. So, yeah, as usual, take that with a pinch of salt. Unless it's a Fluke or some other not main brand multimeter you got from reputable source, then, you know, don't count on it. Because, you know, there's a good chance it's not going to be what you think it is if you take those markings seriously. Would I prefer to have 2 AA batteries in there? Maybe. Would have been better? Maybe. Don't know. At least it's got a proper lip around the outside here, so it's actually, the cases do knit in together. So it does have like a blast shield there, so I want to blow the side out, at least not so easily. And being ABS, then it should be a bit tougher anyway. Should be able to take a little bit of abuse. And it does have these ceramic fuses in there, but I'm sceptical about the actual current ratings. I think it's about 1 milliohm, that shunt. Yeah, I don't know, make it that way you will. Might be interesting for someone. Right. Well, let's put it together, let's see if it turns back on. There, screw still works. Should be good. I think we're alright. So I'm going to leave this here as another bench meter because it's a nice big display, and I've got my, should do a comparison, shouldn't I, actually, my EV log meter. Okay, so you can see comparison there side by side. So it's slightly bigger, it's a bit thinner, not a lot, and obviously height wise it's, you know, a bit different too, but yeah, it's a bit, somewhat bulkier. Weights feels slightly heavier, not a lot in it, but I think between these 2 meters, obviously I think I'd trust this one a bit more. You know, it's Bryman. My own testing with this particular meter here has been proving it's fairly accurate, so it's a good meter which I trust. But sometimes it's nice to have 2 multimeters so you can do multiple measurements at once. And having 2 meters I can chuck on a bench like this is quite nice. I've got my old Digitech one, but it just the display is not easy to see on it, and it's just not very nice. It's a bit old and crappy. And thank you very much, Banggood, for sending this to me. It's very much appreciated. You know, this is I think it's about $100 New Zealand, this meter, something like that. I think performance-wise, it looks okay. As usual with these non-mainstream meters, the whole protection circuitry is just not really up to scratch. So as far as this high voltage stuff goes, don't go there. Right? That's certainly your best if you keep away from those kind of regions with that protection circuitry that's in there. It's got a PTC, but yeah, no MOVs, and that's a bit concerning. There's no MOVs in there, no isolation slots, so you could get arc over potentially. You know, so definitely I would say don't do any mains work with this thing, but you know, that's the way a lot of these non-mainstream meters are. It's okay. I mean, it's alright. If you're looking for a meter which does a lot of functions and has a nice display, automatic backlight, which I think is a nice feature, non-contact voltage, which is nice if you're checking for things in walls, potentially. I should try that actually. And actually, I'm going to try it now. Non-contact. Let's see if I can find a power on the wall. Yep, it can find power on the wall. So you can see if there's a mains cable behind the wall, it does that. So that in itself is worth having. If you want to drill a hole in the wall, you need to know there's a power cable there. Don't find out the hard way. So again, thanks Banggood for sending me this. If you're interested in one of these meters, follow links down below in the description to go and have a look. Or any other meters you might be interested in if you're in the market for a meter. Use the Banggood links down below, because I get a commission on any sales that go through that way, and I actually get, you know, credit on my account and stuff like that. So it doesn't cost you any extra, but I benefit from it, which means I can buy more things from our bag and stuff like that, and get more review items too. So make sure you go and follow those links, because if you follow those links and buy stuff, then it helps me to get items, and it helps me to get more expensive items too. The value gradually increases over time, the better the outcome is for the reviews, as far as Banggood goes. So even if you just follow the link and go and have a look, I'll be happy with that. Alright, so thanks for watching, and thank you very much Banggood for sending this to me, and I hope you found it interesting. If there's anything specific you might want me to check on this, maybe I'll do a follow-up video later on if you've got any specific questions or things you want me to check, anything I may have missed. Yeah, then let me know, and I might do a follow-up video if there's enough questions about it or enough interest. I might just, you know, put comments down below in the comment section there. If you got, just chuck comments in. If you want a question, chuck it down there. I may just be answering the comments, and it might be good enough. But yeah, thanks a lot. I would have a Banggood card here, but I seem to have lost them. Banggood, if you watch this, send me another card, will you, when you send me the next thing. Hope you found it interesting. Catch you later.